This episode of CPPcast is sponsored by Backtrace, the turnkey debugging platform that helps you spend less time debugging and more time building. Get to the root cause quickly with detailed information at your fingertips. Start your free trial at backtrace.io/cppcast. And by JetBrains, maker of intelligent development tools to simplify your challenging tasks and automate the routine ones. JetBrains is offering a 25% discount for an individual license on the C++ tool of your choice: CLion, ReSharper C++, or AppCode. Use the coupon code JetBrains for CPPcast during checkout at jetbrains.com. Episode 127 of CPPcast with guest Dave Moore, recorded November 22nd, 2017. In this episode, we talk about how to benchmark your code. Then we talk to Dave Moore from Oculus Research. Dave Moore talks to us about the Oculus SDK and his work on augmented reality. Welcome to episode 127 of CPPcast, the only podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm doing good, Rob. How are you doing?
I'm doing okay. Getting ready for Thanksgiving.
Yes, that's tomorrow for our listeners who wonder how we time travel.
Yes.
But it's actually yesterday, I guess, if they're listening to this.
Yeah, or maybe a couple days ago if they don't get to it until next week.
A couple days ago, because I had an interesting conversation with some of our listeners in New Zealand that were like, oh, I love when your show comes out every Saturday morning. Like, wait a minute, that's not when we put it up.
Yeah, I love those time changes.
Yeah.
Okay, well, at the top of every episode, I'd like to read a piece of feedback. This week we got an email from Wojtek, and I can pronounce that name correctly because I actually wrote out how to pronounce his name, which I really appreciate.
Wow.
And yeah.
That's perfect.
Yeah. Anyway, he writes in, thanks for the great show. For me, Friday is the first day of the week. What do you say about some guests from Poland? And he has a couple suggestions of notable C++ guests from Poland. And
you should pronounce their names also.
Well, he did not give me pronunciation guides for these names, so I'm going to butcher all these. So there's Andrzej Kresmensky, who's the author of arcsemi.wordpress.com blog, mentioned a few times on the show, and he gave some talks at Code Dive and Code Europe. Bartłomiej Filipik, he also has a blog, bfilipik.com.
Yeah, Bartek, I think he goes by.
I know we definitely mentioned his blog a couple times.
Definitely.
Yeah, and Bartosz Zurgat, who gave a few talks at EMBO, C++, and Code Dive, and he says he actually knows him personally. So yeah, I would definitely be up for having any of them on. You didn't meet any of them when you were at Meeting C++ by any chance, did you, Jason? I know you said you met a lot of other European guests, not just German.
I don't know if I did. There's a lot of people at that conference and a lot of names going around, yes.
Yeah.
Sorry.
It's okay. Well, we'd love to hear about your thoughts about the show as well. You can always reach out to us on Facebook, Twitter, or email us at feedback@cpcast.com. And don't forget to leave us a review on iTunes. I also wanted to mention really quickly that we are on Spotify now. So there's another place where you can go and listen to the show. Apparently, Spotify just started doing podcasts a couple months ago, and we were able to get in there, which is pretty cool. Yeah. And another thing I just want to mention really quickly is everyone on the internet is talking about net neutrality right now. And if you're in the U.S., it is kind of a big deal. I think it's kind of a politically neutral topic. I don't ever want to get, my own political stuff into the show. If you're interested which way I fall on the spectrum, you can look at me on Twitter. But I feel like net neutrality is something that anyone should care about because, if you need to pay extra to get a different internet plan, you might wind up having to pay extra to get to cppcast.com. And that would be horrible, right?
Yes, that would be horrible.
Yeah.
Although we're probably a small enough fish that we wouldn't get singled out, but
Hopefully not, but they might try to get people to pay more to make their websites faster or something like that, and that's not something.
Or just the fact that you're streaming something, perhaps, from the website.
Yeah, exactly. So it is something that could affect podcasts in general. So it's worth calling your congressman if you have a moment to do that. Anyway, joining us today is Dave Moore. Dave started programming after getting fired from his college work-study job. This worried his parents, but it seems to have worked out in the end. After spending 17 years in and around the computer games industry, most recently at Rad Game Tools, he's now a software engineer at Oculus Research, working to advance the computer vision technology underlying virtual and augmented reality. Dave, welcome to the show.
Thanks. Happy to be here. That was a sweet work-study job I got fired from, too.
That's what I was wondering. What was it?
It was a job in the registrar's office, which was a real cush work-study job. You file people's grades, you sort of go look up transcripts. So, but the reason that I transitioned to programming is I'd been spending nights, teaching myself, C and C++ down in the lab, and managed to sleep through registration day morning, which is, it turns out, the only day you can't be late for work if you work at the registrar's office. So, like I said, it worked out in the end.
Okay, so this is fascinating, I think, maybe. Was C and C++ your first programming languages?
It was, yeah. So my family didn't have any computers that had compilers on them. So the first contact I had with a programmable computer was a Unix mainframe in college. So I started with GCC and just worked up from there.
Okay. If you don't mind my asking, what was instead of asking you what year that was, I'll ask, what GCC version was that?
Oh, wow. It's way back. It was in the 1 or 2 series, right? So, no, I graduated from college in 97. So this was pre-C99. This was after, I think, most of the C++ had sort of settled out. But I was not any great shakes back then, for sure, as a programmer. So, I don't even remember the details of the language mostly, so...
Well, that's cool. I mean, I've had some conversations lately with people about teaching C++ and learning C++, and
yep.
I started with BASIC, and I remember very distinctly that actually learning how to do structured programming, why would I want a function? And what would that gain me? That was a huge learning curve for me. And I was wondering if learning in C on Unix mainframe, is there any particularly brain damage that you got, or maybe good experience that you got from that?
So I was actually particularly lucky. I went to Reed College. They had an academic software development lab, which was a really sort of fancy way of saying the people who administer the Unix mainframe. But, they had some people who, like to program and would do little projects for the professors. So I had a bunch of really good tutors and mentors, including people like Nelson Minar, who went on to do a whole bunch of stuff at Google after he graduated from Reed and then the Santa Fe Institute. So I had really, really good teachers. So hopefully not too much brain damage. And then I got some internships at a local game company in my hometown during my college experience as well.
Oh,
so I also
awesome.
got good practices beat into me there as well.
That sounds like fun and interesting because the games industry is not necessarily 100% known for programming with best practices.
Correct. Yeah, for sure. But Dynamics back in the late 90s.
Dynamics.
It was a great place. I very much lucked into that. I grew up in Eugene,
Okay.
got my first job there by just dropping a resume off at the front desk, which is a harder thing to do these days. Now there's actual, courses of study to become a computer game programmer. So it's a little bit more difficult to do it that way. But like I said, I lucked out.
Yeah, I wonder how many of our listeners you just made supremely jealous for being able to get that opportunity.
I know, because you bump into people, just starting their careers at GDC or whatever, and it's really common to get asked the question, how do you break into the games industry? I just have to say, I have absolutely no idea.
Right.
So
that's awesome.
Okay, well, Dave, we got a couple news articles to discuss, and then we'll start talking to you more about Oculus and your work in the research team and the SDK, okay?
Sure. Yeah, absolutely.
Okay. So this first one is Chirp, and that doesn't sound quite right to me, but I guess that's how you pronounce it, and that's the C++ compiler for the web. And Jason, we haven't really talked a whole lot about WebAssembly since we first had JF Bastian on a year and a half ago. But,
yeah.
But this
It's
seems
a thing
pretty.
now.
It's a thing now, and there are now enterprise compilers that are targeting WebAssembly to
and
competing with Emscripten, I guess.
when I first saw the link, I'm like, I already have a web-based compiler. It's called Compiler Explorer.
Yeah, but that's not what this is at all.
This is not what this is at all. No. But yeah, I just saw news, what was it, just a couple weeks ago, that now all three of the major web browsers support WebAssembly. So,
Yeah. And looking at this a little bit, it seems that even if you still need to worry about older browsers, like I guess old Internet Explorer or something that don't have WebAssembly support, it can compile to both WebAssembly and JavaScript at the same time.
wow.
And then the browser would just use whatever's better. So that's pretty cool. It's this Chirp claims to be faster and compiler to a smaller size than Emscripten, and it does have an enterprise grade support. Or if you are working on an open source project, you could use it as long as you're comfortable with that license.
I'm going to have to give this a try at some point. Is this anything that you've worked with, Dave?
No, that would be something much more interesting probably to people on the Facebooky side of the business, right? I mean, Oculus is owned by Facebook. We're still almost certainly the only Fortune 100 company that ships most of its code in PHP. So this would probably be super interesting to someone who does that. But the inertia of that is still pretty amazing. So,
Wow.
yeah.
And it's a special flavor of PHP that gets compiled to C++ or something. Is that?
No, well, so they do have their own internal special flavor of PHP where they've added things like static type checking and, any type checking at all, actually, right? So, but I think they sort of made a pretty mature engineering decision that was like, we could sit back and rewrite all of this, or we could keep what we have, try and improve the environment around it, and that's worked out pretty well for them. I don't have anything to do with that side of the business, though. So,
Right.
Sure. Okay, next article we have the wrong way of benchmarking the most efficient integer comparison function. And this is on the Old New Thing blog, which is Raymond Shentz from Microsoft, which is always a really good blog to read. And he's going over different ways of benchmarking, kind of really simple code, and actually going through, and it looks like he used Compiler Explorer in this to actually look at how the assembly between some of these different comparison functions works.
Yeah. I think a great takeaway from this was, the original test was summing the results or something. And he said this is a useless test because you're not using the function in any way that would actually be used.
Right. So he writes a benchmark test that's actually doing a legitimate usage of the code that you're trying to benchmark. And that's his big argument, that you should always be really using the code. Otherwise, the compiler's optimizer might not behave the way it would in a real world scenario. Yeah.
And I think this is only the second time we've mentioned Raymond Chen.
Maybe. I know he's always writing really great blog posts, though.
yeah, I love that blog.
I just thought, I would mention that if our listeners don't know, I mean, he's been around for 14 years as he's been writing articles consistently. There's a lot of articles on his website.
Yeah, and actually, looking at his website right now, it looks like he actually wrote a book called The Old New Thing. That might be worth looking at.
I don't think I knew that.
Yeah.
I always check his blog whenever I've got frustrating questions about Microsoft software, like why don't they just do this? And then you go to Raymond's blog and you find out why they don't do that, or why they did it the way they did it.
That is true.
Yeah. Okay, this next thing is PackXX, Programming Accelerators with C++. And it looks like this is another kind of replacement for CUDA. And this one has C++ 11 and 14 support. And Dave, this sounds like something you might be familiar with, because it's
that honestly, was
improving GPU
we haven't.
speed.
Yeah, we haven't played around with this particular library, but that's definitely right up our alley. There's tons of stuff that we use CUDA all over the place on both the VR and the AR side of Oculus Research. So anything that makes that easier, or brings the programming models closer together, is way better. So we'll keep an eye on it for sure.
And then this last article we have from Funathan's blog, what should be part of the C++ standard library. And I thought this was a pretty interesting article. He starts off by talking about the 2D graphics proposal, which Guy Davidson, who we've had on the show, has talked about. And, maybe a lot of people won't really be using that, but, is there going to be some benefit from standardizing it? And he goes into kind of an in-depth thing where he talks about, in a perfect world, what would C++ be like and what should be standardized and what shouldn't be. And he goes into the whole, you remember the left pad controversy that happened with all those JavaScript libraries a while ago? So yeah, we definitely don't want to go that far where we use everything from libraries, even if it did become trivially easy. It definitely makes sense to have things in the standard. I don't know. What did you think about this, Jason?
I think he did a good job of covering the various issues around deciding what should or shouldn't be in the standard library. And, I feel like he mostly left the question open. What should or shouldn't be in the standard library. Yeah.
And he kind of finishes up talking, maybe this 2D graphics doesn't need to be there, but, there would still be some benefits like having new vocabulary types that then other graphics libraries could use in their own library. Yeah.
Yeah.
Dave, is this something you think Oculus might build upon if there was a standard graphics library?
If there were vocabulary types, those would definitely come into use. It's interesting at Rad, we shipped on so many platforms. We were way, way behind the standard. In fact, all of the APIs that we shipped at Rad were in C, right? So internally we implemented them in C++ or did whatever, but sort of the public facing version of all the APIs was straight C just because that's the most binary compatible. You've got, linker support across tons of different compilers. At Oculus, it's, we've advanced a little bit farther, but if you look at the Oculus SDK header, at least at one point, it still parsed as straight C at one point. And it sort of had that sort of suit and tie, very conservative external facing, front. But, any sort of, vocabulary types relating to 3D math or spatial computation would be super useful. And those would probably go in for sure.
Cool. Yeah. Well, let's talk a little bit more about what your role is on the Oculus team.
Yeah. So Oculus Research used to be very distinct from the main Oculus team that ships the headsets and sort of works on the software systems that people, you go to Best Buy, you buy an Oculus headset, you install our software and start playing games. That's the part of Oculus that's sort of headquartered in Menlo Park. Oculus Research is we're located in Redmond, Washington, primarily, and we're focused on pieces of the virtual reality experience that aren't in the shipping headset and aren't maybe even in the next shipping headset. Is sort of the cartoon way to say it. And what that means in practice is we're doing a whole bunch of stuff that can fail, right? We're not on a shipping timeline. We don't have manufacturing deadlines to hit, that sort of thing. So we're sort of asking questions where we're not sure if the answer is yes or no or maybe or not yet. And so we're doing that for both virtual reality, obviously, which is the headsets that you can go out and buy now, but we're also starting to explore augmented reality. And there's various flavors of augmented reality, but the sort that Facebook and Oculus are really interested in are sort of see-through glasses style AR, right? You put some very small, lightweight device on your face, and it augments to the real world rather than completely replacing it, which is what virtual reality does. And so what I'm doing for that right now is I'm working on one of the teams that is extending the ability of the headset to sort of understand its position in the world and start to understand the position of other things in the world. The specific algorithm we're working on is called SLAM, which is simultaneous localization and motion. And if you want sort of a block diagram like cartoon version of what that is, if you have a wireless headset, let's say it's an augmented reality headset, you want to be able to use that out in the world. You can want to be able to walk out of your house and walk down the street and get restaurant recommendations or whatever sort of overlaid on the real world. you can't have any infrastructure out there that's telling you where you are, right? You don't have any tracking stations. You don't have any cameras that are observing you, telling you where you are. You sort of have to put sensors on the headset that observe the real world and then sort of make inferences about where you are.
Right.
And so in really rough terms, these algorithms basically ingest camera images and accelerometer data, and they spit out position information. They tell you where you are and where other things in the world are. So I'm having a blast doing that. It's not anything like I've done before. That's obviously nothing like computer games, but it's a lot of fun.
So is your ability to capture, and maybe I'm already going way off into the weeds, but I'm really curious, if your ability to capture gyroscope and accelerometer information with compass headings and whatever, like I've played with some of the 9 sensor orientation chip kind of things. Well, I've read the specs on it, and I own one. I haven't played with it yet. Anyhow.
You should. They're a lot of fun.
I'm sure. Well, that's why I bought one. I thought it would be fun. Is the information good enough? And I guess this is where you're leading, is if I were to have this device and I'm capturing all the information from it, and I go walk down the stairs and out the front door, would you be able to build a 3D model and say this person traveled down so many feet and north direction by so many feet without having a GPS to augment it?
So there's a couple of things in there. So let's start with just your 9-axis accelerometer. So are you asking with camera information or with just the accelerometer?
I was curious about the accelerometer, but go ahead and fill in whatever details you can.
Let's sort of work our way up, because it sort of explains, if you look at one of these systems, there's a reason for everything that's there. So if we just started with the accelerometer and gyroscope, right? So we just have that measurement of sort of the derivatives of your motion rather than the motion itself.
Right.
Right. It's telling you how fast you're turning or how fast you're accelerating. We can, over short time spans, like a walk down the stairs, be very accurate about the changes in your heading, because we only have to sort of integrate that once. We have information about your rotational velocity. With an accelerometer, if you try to infer like a total change in position, after about a second, it becomes wildly inaccurate, because you're integrating twice. And so what happens is you pick up from that first integration some dirt, right? Some just like noise in the system, because none of these devices are perfect. And that accumulates into your velocity, and it does sort of a random walk, and you just wind up zooming off to infinity if you try and infer from only the accelerometer. So, and I encourage you to try it out, because it'll be really obvious to you when you play around with this. So then things get complicated, because now you have to add some system that has an absolute reference to it, right? Or at least a stable relative reference. So for the Oculus VR headsets, we accomplished that with what's called an outside-in tracking system. So when you go buy one of the headsets, there's a little positional tracker that you mount on the wall or your desk, somewhere fixed. And that is a sensor that is observing the headset, but it's from a known position. It doesn't drift. It's got, a lower... It takes longer to process your position, and it is very sensitive. Right, your accelerometer works the same no matter where you are in the room. The farther away you move from that positional sensor, the lower resolution we have, or the lower resolution the information about your position is. So that's how you solve it in VR, when you can sort of, when you're tethered to a computer and you can have outside-in tracking systems, that works fine. For AR, it gets much more complicated, because now you would put, say, a camera on the headset looking out, or even just
GPS.
Multiple cameras. So GPS is an interesting one, because that's zero drift. It works everywhere, but it's also very, very low precision. Okay. So if you needed to do something like, say, how far away is this virtual orange from my head, GPS can't do better than a meter or so. Especially indoors, it'd be way worse than that. So it's not really great at correcting those errors. Cameras are really good at correcting those errors. But the process of extracting a relative track, observing the changes in your headset position, which changes the image of the stairs as it's moving past you from the point of view of the VR headset. That's why we have PhD computer vision researchers. It's not an easy problem. And that process itself has drift to it as well. So that's why then you have to build up a map of the world, so you can sort of observe. If you imagine turning 360 degrees in a circle, the camera images when I'm facing forward have nothing to do with the camera images that are coming into the headset when I'm facing backwards, right? You have to build up a relative track that gets me all the way there and all the way back. So it's a really, really interesting area of research. The algorithms are not particularly new. The ability to do them in real time on devices that are sort of consumer relevant is pretty new. So, I mean, the Microsoft HoloLens is a great example. Their tracking system is spectacular, and, fits into, it's not a comfortable headset, but it's something you put on your head. It's battery powered. It's embedded. And it does AR augmentation really, really well. So.
I want to get back to the SDK, but since you brought up the HoloLens, the only AR I'm familiar with was the HoloLens and then the Google Glass, which obviously kind of failed and no one's using those anymore.
Yeah.
Is it something like that Oculus might be working on, or can you not say? I mean, I guess it's research, so it's all very speculative you're working on.
So luckily, of course, whenever you go and talk publicly, you got to go and clear all your topics. And one of the nice things is that Mark Zuckerberg and the lab director for Oculus Research, Michael Abrash, have given lots of public talks. So anything that's in those talks is fair game, because it doesn't get, much more public than whatever Mark Zuckerberg says. So in this case, I can't talk about that. So Google Glass and HoloLens are in the line of what we're interested in, for sure. Google Glass did not register augmentations against the world. It was sort of an annotation that hovered in your viewpoint.
Right.
That's not probably as interesting to us. We definitely want to be able to register things against the real world, so that it can recognize things in the real world, tell you things about them, help make you smarter, all of those sorts of sort of knowledge augmentations. HoloLens is, as I said, super impressive. But for Facebook wants virtual reality and augmented reality to be a part of people's everyday lives. And if you've seen a HoloLens, you can't really imagine sort of walking out your front door wearing it and going to the store with the thing on.
I have had a chance to wear one. It's definitely not something you'd walk around with for a long time.
Exactly. So, and, there are real sort of plausibility challenges to say, can we make something that looks like a pair of glasses? Or even, something that's not a pair of glasses, but is socially acceptable, sort of avoids the problems that Google Glass has, that doesn't, that you would wear outside. And we have an optics team working very hard on some of those challenges. And, there's there's programming challenges there as well.
So can you speak to, you said the ultimate goal is, augmented reality that you would use all the time, but like what kind of information or what is the goal? Games? Is it, what?
So, games are definitely part of it. For Facebook, if you think about the population of people that play computer games versus the population of people that use Facebook, even setting aside characteristics, I mean, they're vastly different orders of magnitude, right? Facebook really believes, and I think most people at Oculus Research, myself included, really believe that the real power of this is to collapse distance, to enable sort of, non-local social interactions that are meaningful, right? Like if I can put these glasses on and feel like in some sense I'm in the same room with someone that's not right next to me, that collapses social space in a way that's really interesting. If I can put these glasses on and have an asynchronous social interaction in the same way that, say I like a restaurant on Facebook and it comes back and then recommends that to my friends when they happen to be in the same town, those are really interesting interactions as well. And I think that's the sort of thing that Facebook has its sort of long-term eyes on, are these interactions that are going to be meaningful to, millions or hundreds of millions, or even, Facebook user scale is billions, right? That's where they've got their eyes on augmented reality.
Wow.
Okay. I wanted to interrupt this discussion for just a moment to bring you a word from our sponsors. Backtrace is a debugging platform that improves software quality, reliability, and support by bringing deep introspection and automation throughout the software error lifecycle. Spend less time debugging and reduce your mean time to resolution by using the first and only platform to combine symbolic debugging, error aggregation, and state analysis. At the time of error, Backtrace jumps into action, capturing detailed dumps of application and environmental state. Backtrace then performs automated analysis on process memory and executable code to classify errors and highlight important signals such as heap corruption, malware, and much more. This data is aggregated and archived in a centralized object store, providing your team a single system to investigate errors across your environments. Join industry leaders like Fastly, Message Systems, and AppNexus that use Backtrace to modernize their debugging infrastructure. It's free to try, minutes to set up, fully featured with no commitment necessary. Check them out at backtrace.io/cppcast. Well, let's go back to the Oculus SDK a little bit. For listeners who haven't done any game dev work, which is probably most of our listeners, and are interested in starting with the Oculus SDK, kind of what's the intro point? And if you are a game developer, what is it like to work with the Oculus SDK compared to the more traditional gaming SDK?
Yeah, so it's an interesting question. First of all, there's if you go to Oculus.com, there is just a developers tab, and you can just sign up and download the SDK. So I would encourage everyone who's curious to just go do that, because you can even just go look at the headers, even if you don't have the headset, and start playing around with it. The Oculus SDK is narrowly focused on, right? So if you think about something like Unity, which is a game engine, right? It tries to, provide you with a framework that you can develop a complete game in. And the Oculus SDK is a much more narrow thing. It's more like an audio SDK or, some sort of device-specific SDK. It's focused on taking the images that your game rendered and then presenting them to the user inside the headset. So it's concerned with things like taking the left eye and right eye buffers and getting them onto the screens at the right time. So in that sense, it's much more like using a little bit like using OpenGL or something like that, right? It's very focused on sort of the position of your head and how that sort of changes the way that you render the game world, and then getting those images onto the headset. So you can't write a full game in the Oculus SDK, but once you have your game, it's pretty easy to sort of take that and then modify it so that it works in VR. It's a kind of an opinionated SDK in the sense that, so we've gone through a lot of revisions of it. So all the way back from the API that we were shipping with the Kickstarter, which was, we sort of threw a lot more of the choices onto the developer. Like, how do you distort the eye buffers so that, it compensates for the distortion that is just a reality of the optical system of the headset? We take over all of that now. I think you may be able to still work around it, but it's not it's not the default path anymore. And the reason we do that is just that the reality of VR is that there are so many choices that you have to make that can have a negative impact on the user. Even things like, the frames in the Oculus Rift are being presented to the user every 11 milliseconds. It's 90 frames a second. And skipping even one of those frames or missing it or presenting it at the wrong time can actually have real physical consequences for people. You can make them sick. You can make them nauseous. You can cause what I call the nope reaction, which is where you just reach up and rip off the headset. And so there's a lot of sort of, we take over a lot of the details just because it's easier for us to do them than for developers. If we start to understand the system better, we can upgrade it from that point. So that's the PC side SDK. I don't have as much experience with the mobile SDK, but that's a native Android application SDK that you can also download that works for things like the Oculus Gear, the Gear VR headset that we ship with Samsung, or the Oculus Go headset that we announced at our last Connect.
So if you're a game developer and you're using any sort of game engine, would I be correct in assuming that the game engine itself might have Oculus support? Yeah. And so you wouldn't have to rewrite anything yourself if your game engine is already supporting Oculus?
Correct, yeah. So Unity and UE4 both ship with Oculus integrations now, and we work very closely with them to make sure that those are up to date and, just work right out of the box. You have to make... depending on the sort of game you're working on, you have to make some changes, possibly even to the design of the game, but the integration with the engine should be relatively trivial. Like a lot of times, I worked on console and PC games for a long time, and you'd have cinematic scenes where you would grab the player's viewpoint and whip it around and show them exactly what you want to show them. In VR, if you're not very, very careful, that's also a very bad idea. If you start grabbing someone's viewpoint and accelerating around, you're going to make them sick pretty quickly. So it's a mindset change for some people, but it's not as novel a concept as it was 3 years ago.
When you're working on this and working in the research, have you had people fall down or vomit or something while testing?
Almost never a reaction that strong.
Almost never.
So I unfortunately I can't be absolute because I don't know everyone that's been in there. But I can talk to my own experience. So I used to work for a while on the tracking for the VR headsets, and when you're doing that, you put breakpoints in the code or you have bugs, and certainly the most disconcerting experience I've ever had in VR is, if I hit a breakpoint in my code, it freezes the world, basically. And if you're turning your head, it suddenly feels like someone stuck a big thumbtack right into your forehead and the world starts dragging along with you. So that's the nope moment that I mentioned where you just rip the headset off. So you get used to it after a while, but and the people are more or less sensitive to it as well. So a lot of the work that's been done on the SDK is literally just because we start to understand those issues better and can mitigate them better. But we also put up big warnings that say, hey, observe yourself, don't push. And we tell developers these things so they can make the experiences more comfortable for their user. It's a huge focus for Oculus.
I'm curious, and I guess I'm taking a step back in the conversation. Sorry, Rob, but since we were just talking about the tracking and you're talking about, the possibilities of actually making the user ill to some extent, how much effort has it taken to get that tracking feel as real time as possible so the user feels like they're in this and there's no this lag as they're turning their head or whatever?
That has gone on for 3.5 years. It's still ongoing. There's a whole computer vision team at the, working on the Oculus product itself that's still working on the tracking for the headset, that's working on the tracking for new headsets, as well as, the work that we're doing at Oculus Research to enable different form factors in the device. There's always, I talked a little bit about how accelerometers and gyroscopes are not perfect devices because they have noise, right? They have little stochastic variations. They're physical devices, so when they measure things, they get it a little bit wrong, and there's some randomness in the system.
Right.
The better you understand the character of the noise in the system, and the better you are able to understand the character of the noise in your other sensors, like the positional tracker that's out in the world, there are mathematical techniques that you can use to compensate for that. It's not giving away technical secrets, luckily, because we've talked about it before. Oculus uses what's called an extended Kalman filter to do the tracking, that to take these multiple input sensor streams and combine them into an estimate of the user's head position, because that's all we have is an estimate, and it has some associated uncertainty. And the better you understand the noise in your sensors, and the better you understand the noise in your computation, and the better you understand the user's head motion itself, right? What does a typical user do in the situation? If my head is at rest, I happen to be 6 feet tall, so let's say 6 feet off the ground at zero velocity, I'm not going to suddenly be upside down 3 feet off the ground in the next frame. That's really unlikely. So the better you can model the user's behavior as well, the better your estimates of their true position are, and the more comfortable the experience. That work is always ongoing. So,
interesting.
Yeah,
Thank you.
It's a lot of fun. I will say that's been picking up that mathematical framework has been the most fun for me, because there's nothing like it in computer games. This only happens when you have all of this sort of noisy observation of the real world, and then you have to sort of incorporate that into some sort of programming system. And so it's a lot of fun.
Are you working on that in C++?
Yeah, absolutely. Oh, wow. Nice bringing it back to the main topic. Yeah, so all of this internally is C++. A lot of the prototyping, when we have people doing mathematical work, a lot of the first prototypes are done in MATLAB, but ultimately, like I said, we're putting images up on the headset at 90 frames a second, we have to estimate the position of your head even faster than that. We estimate the position of your head at a kilohertz. So all of that is extremely performance critical. All that works in C++.
So I'm aware that a lot of mathematical stuff is prototyped in MATLAB. Do you have any techniques for porting from MATLAB to C++?
I wish, not really.
Okay.
So typically you're not talking about. It's not like we're porting, 7,000 or 8,000 lines of MATLAB. Typically, the underlying mathematical kernels of these things are maybe 20 or 30 lines of code, because MATLAB is super compressed that way. And we deploy. We use. There's a whole bunch of libraries that make that a lot easier. We use. Mostly at research, we use Eigen for large matrix to matrix or matrix to vector work, or doing matrix factorizations, which are important for these mathematical frameworks. So that compresses a lot of it. That takes a lot of the work out of our hands. On the Oculus side, they use a library called Tune for doing the same thing, which is another templated matrix library, which makes it a lot easier.
Okay.
So I think you said that Oculus has been around for about 3.5 years, which brings you, you started off when C++ 11 was already around, if not C++ 14. Are you able to use the most modern versions of the compilers?
So Oculus Research has been around for 3.5 years.
Oh, okay.
Oculus was around for another year before that as a Kickstarter. Oculus Research was basically founded when Facebook acquired the company. So that gives you that date. So we were... For the stuff that we ship to end users, I think internally they use C++ 14 constructs, but the stuff that we export to the end users is, again, sort of suit and tie, very conservative, because we don't know what compilers they're going to be using.
Okay.
At Oculus Research, we sort of have much more control over that because we're not shipping anything to end users. So we're on G++, whatever. I'm actually working on Linux rather than Windows, so it's we have even a little bit more control there. So we use C++ 14 concepts as well. Although we also have interactions with CUDA compilers, which sometimes choke a little bit on some of that stuff. So we try to be conservative there as well.
Are there any specific C++ 11 or 14 features that you find useful to get some of this performance critical work done?
It's an interesting question, and I thought about it a little bit, obviously, before coming on the show. We have a lot of people from the games industry at Research and Oculus, of course, and we tend to be pretty conservative about the abstractions we deploy because we need to understand everything that's going on under the hood. So things like unique pointer or auto, some of the stuff that's really easy to understand all the way down to the disassembly, all of that stuff gets deployed all the time. We're just starting to write some internal stuff that uses, futures and restructuring some multi-threaded code that way, on my team at least. I can't speak for everywhere else in the organization. One of the interesting things about research is there's tons and tons of different projects going on, and the teams sort of select the appropriate level for themselves. So that's my team. We tend to be, at C++ 14, we're not taking on board any 17 stuff yet because, for internal reasons, let's just say we have to be a little bit conservative because there are some blessed compilers that are important in the Facebook ecosystem, and those I believe are 14 right now and not 17. Okay. So, but we're taking on board the stuff that is useful for sure. There's, like I said, unique pointer and stuff like that. It's a no-brainer. Auto works really well for us, but we're pretty conservative in general.
So you stated that you work on Linux, and you've also said that the SDK works on with many different game engines.
Yeah.
Can you deploy Oculus games on every platform?
Sadly, no. Right now, it's Windows only, and a lot of that. Yeah, I know, right? So Windows plus Android, let's say, because the mobile platform is really important as well. So those are two different SDKs, though. The Windows only thing was a decision they had to make basically when we were shipping. The timings of how images get presented to the user, right? are super, super critical. And right now, it's only on Windows that we have the sort of driver support that lets us control that all the way down sort of to the level of the HDMI scan out.
Interesting.
Right, because if you think about, we talked about delaying images by 11 milliseconds, causing the user to feel uncomfortable or that their head motions weren't being immediately represented in reality, right? If I turn my head and the world sort of drags behind it by 11 or 22 milliseconds, that's really bad. It feels very, very bad is the only way I can say that. And you can compensate, if you know that's happening, you can compensate for it by just predicting the head position forward 22 milliseconds. But that prediction forward is not perfect. It's not the same as knowing exactly where the user's head is. So right now, it's really only on Windows that there's broad support for AMD and NVIDIA and Intel graphics cards to control it all the way down to that level so that we know exactly how much latency there is in the system.
Is this an issue that you believe is solvable at some point?
I think so, for sure, yeah. Certainly, I would love to have Linux support, but I'm not actually sure what the plans are on that side. That would be something... The other thing, of course, is that the driver for the headset is only one component of the ecosystem as well. Oculus has to ship its platform software on Linux. They have to, which is probably not a significant issue. There's no comparable sort of, the drivers don't work as well issue there. So we could probably solve that, but it's another thing. So that would be a decision for the Oculus product team to sort of assess when that's ready to go.
Okay.
You mentioned the Oculus Mobile SDK. So that's putting an Android device into the headset, right?
Yeah.
Is that also a C++ SDK? Is the code you write for the Oculus Rift similar or the same as the code you write for Oculus Mobile?
So, yes. I think the broad strokes of the SDK are the same, although this is where I'm on really shaky ground because I haven't looked at that SDK in a long time. You're still mostly concerned with taking a left eye buffer and a right eye buffer and then presenting that to the user in the fastest possible time. And I think most people that are writing games for Gear VR definitely do that in the native API, right? They're writing C++ code right to the metal. They're not using the Java layer of Android. Although I think that may be supported, but probably not recommended unless you're doing something real. If you're rendering a couple of rectangles in the world to just show people video or whatever, maybe that's sufficient. But if you want to do an actual game, you're definitely going to be in C++. You need access to all of the hardware. You don't want anything in your way.
I just am curious a little bit more about the Oculus hardware. Like, what kind of resolution is it able to display?
So the Oculus Rift is, in rough terms, it's probably about 1,000 by 1,000 for each eye.
Okay.
It's an interesting. So that's just in raw pixels because you can take these things apart and just look at the screens. The more interesting metrics for VR is sort of pixels per degree, right? Which is not the normal sort of thing you think about when you're thinking about a monitor or a 4K TV or whatever. But in this case, you have to take those 1,000 pixels horizontally, let's just sort of arbitrarily say, and you have to spread them over 90 degrees or 100 degrees in order to create a large field of view.
Right.
And if you do the division there, and sort of ignore optical aberrations or whatever, you're talking, roughly 10 pixels per degree or five cycles per degree, which if you go to an optometrist and say, at normal distances, I can see, 5 transitions from white to black per degree, they will tell you that you need vision correction or you're not allowed to get in a car, right? So all of the headsets that are out there right now are they're amazing. They provide people with really cool experiences. They were magical enough to make me change careers, but they're really, really far from sort of the limits of the human perceptual system. Okay. And so part of that is we're just tied to the screen technology that was available. No one needs a 10,000 by 10,000 pixel phone screen because you hold it at arm's length. That would be a complete waste. So no one's made those. And so VR is just getting to the point where we can start to drive screen technology to start to drive, drive the panels and display options that are available towards things that are more appropriate for fitting up against the human perceptual system. So the Gear VR, just to give the other number, is it's roughly in the same class. I think it has a little bit more horizontal resolution just because the Samsung phone is really, really high res on its long axis. So, but it's in the same general class. Yeah, and that's the same thing for the Vive or the PlayStation VR. They're sort of in that same general resolution class.
I was just thinking from your conversation about augmented reality at the beginning, like I could be wrong, but it feels like augmented reality, having high resolution, seems to feel more important to me.
It is. Yeah. So, yeah, if you have low-res pixelated augments that are sort of registered against the very high resolution. I mean, the world is always at perfect resolution, right?
Right.
It has zero latency. It has zero drift. It doesn't ever move unless you push on it, which is really inconvenient for us because we have to sort of get to that fidelity level before things get interesting. The interesting thing about augmented reality is the level of optical challenge there is orders of magnitude more complicated than virtual reality. Virtual reality right now, all of the headsets, if you sort of, you go to iFixit or whatever, and you look at the teardowns of the Vive or the Rift or the PlayStation VR, all the optical architecture for all of them, if you just wrote it on a Post-it note, would be magnifying lens in front of cell phone screen. That's all of them right now. And so if you try to get to a system where you have to steer photons into the eye in a way that makes you perceive objects in the real world, but you have to also let the real world through at the same time, we can't do magnifying lenses in front of the cell phone screens anymore.
Right.
So the optical challenge there is really, really hard. And if you look at the Microsoft HoloLens, they're doing it with waveguides, which is an amazing technology. But the HoloLens is actually really, really high res. It's just very low field of view. So that's kind of how they cracked that nut.
Yeah, I've tried the HoloLens, and when you put it on, you kind of get instantly a little bit disappointed with the field of view. It's just not what you would expect from like watching someone else use it.
Yep, they put out those amazing videos, right? Which sort of you put it on and you're like, okay, I understand why this is this way, but you expected the huge globe that you could see the whole thing, and we're just not there yet. The problems of optics haven't been solved in that domain, which is why we have a huge team of really, really smart optical scientists and research working on those problems.
Okay, well, is there anything else you wanted to share before we let you go? Is there like an Oculus Research dev blog or anything like that listeners could look at?
There are, I would encourage everyone, if you're interested in any of this stuff, I would say a couple of things. First of all, if you search for Michael Abrash, VR Talk, whatever, on your favorite search engine, you'll see the director of Oculus Research, Michael Abrash, obviously very well-known games programmer, goes into a lot more detail than I did on a lot of these things, and sort of covers more broadly what we're working on. And then the other thing I would say is, if you would like to help, we are always looking for strong C++ programmers at Research. So if I can plug that, I don't know if that's allowed on your show.
Go for it.
But if any of that sounds interesting to you, drop us a line. And you can just find us at oculus.com.
Okay. Well, thank you so much for your time today, Dave.
No, absolutely. I had a blast.
Yeah, thanks for joining us.
Thanks so much for listening in as we chat about C++. I'd love to hear what you think of the podcast. Please let me know if we're discussing the stuff you're interested in. Or if you have a suggestion for a topic, I'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. I'd also appreciate if you like CPPcast on Facebook and follow CPPcast on Twitter. You can also follow me at Rob W. Irving and Jason at LeftKiss on Twitter. And of course, you can find all that info and the show notes on the podcast website at cppcast.com. Theme music for this episode is provided by podcastthemes.com. Website at cppcast.com. Theme music for this episode is provided by podcastthemes.com.